Grade 7, Chapter 1, Integers. Introduction. Integers form a bigger collection of numbers which contains whole numbers and negative numbers. They can be positive or negative numbers, but they do not have decimals and fractions. For example, 25, 784, minus 67, minus 10,237 are the integers. 3.8 minus 97.05, 6 by 13 minus 4 by 29 are not integers. In real life, positive integers can be: first, our body temperature above zero; second, the money that we earn. Negative integers can be temperature below zero, for example, freezer; second, money that we spent. Recall. Given below is the integer number line with negative integers and positive integers. We note that 0 is neither positive nor negative. Positive integers increase in increments as we move towards right. Negative integers are the mirror of the positive integers towards left of 0. Though negative integers look getting bigger, they are actually getting smaller. For example, minus 19 is smaller than minus 7. The rules for negative and positive numbers. Two like signs become a positive sign. For example, plus into plus is equals to plus, and minus into minus is equals to plus. Example for plus into plus is 3 plus into plus 2 is equals to 3 plus 2 is equals to 5. Example for minus into minus is 6 minus into minus 3 is equals to 6 plus 3 is equals to 9. Two unlike signs become a negative sign. Plus into minus is equals to minus, and minus into plus is equals to minus. Example for plus into minus is 7 plus into minus 2 is equals to 7 minus 2 equals to 5. Minus into plus example is 8 minus into plus 2 is equals to 8 minus 2 is equals to 6. Properties of addition and subtraction of integers. Closure under addition and subtraction. The closure property under addition and subtraction states that the sum or difference of any two integers will always be an integer. That is, if x and y are any two integers, x plus y and x minus y will also be an integer. For example, 3 minus 4 is equals to 3 plus into minus 4, that is equals to minus 1. Minus 5 plus 8 is equals to 3. Commutative property. The commutative property of addition states that the order of terms doesn't matter. The result will be the same. That is, swapping of terms will not change the sum. Suppose x and y are any two integers, then x plus y is equals to y plus x. For example, 4 plus into minus 6 is equals to minus 2, and that also equals to minus 6 plus 4. But subtraction, that is x minus y is not equals to y minus x, is not commutative for integers and whole numbers. For example, 4 minus into minus 6 is equals to 10. Minus 6 into minus 4 is equals to minus 10, which implies 4 minus into minus 6 is not equals to minus 6 into minus 4. Associative property. The associative property of addition states that the way of grouping of numbers doesn't matter. The result will be same. Let x, y and z be any three integers, then x plus into y plus z is equals to x plus into plus z. Example, 1 plus into 2 plus into minus 3 is equals to 0, that is equals to 1 plus 2 plus into minus 3. Subtraction of integers is not associative in nature, that is, x minus into y minus z is not equals to x minus y into minus z. Example, 1 minus into 2 minus into minus 3 is equals to minus 4. 1 minus 2 minus into minus 3 is equals to minus 2, which implies 1 minus into 2 minus into minus 3 is not equals to 1 minus 2 minus into minus 3. Additive identity. The additive identity property states that when any integer is added to 0, it will give the same number. 0 is called additive identity. For any integer x, x plus 0 is equals to x is equals to 0 plus x. Example, 3 plus 0 is equals to 3, that is equals to 0 plus 3. Multiplication of integers. Rules for multiplying integers. When multiply two integers with the same sign, positive into positive gives positive. 2 into 5 is equals to 10. When multiply two integers with two negative signs, negative into negative gives positive. Minus 2 into minus 3 is equals to 6. When multiply two integers with one negative sign and one positive sign, that is, negative into positive gives negative. Minus 2 into 5 is equals to minus 10. Product of three or more negative integers. Example, when the product of three integers is given, minus 6 into minus 4 into minus 3, we follow the steps. Step 1. We multiply the first two integers, minus 6 into minus 4, and then multiply it with the third integer. Under step 2, we get the answer as 24, which we multiply with the third integer 3. 24 is positive, as negative into negative is positive. Under step 3, we get the answer as 72. Hence, minus 6 into minus 4 into 3 is equals to 72. Properties of multiplication of integers. Closure under multiplication. The closure property under multiplication states that the product of any two integers will be an integer. That is, if x and y are any two integers, x into y will also be an integer. Example, 6 into 9 is equals to 54. Minus 5 into 3 is equals to minus 15. Commutativity of multiplication. The commutative property of multiplication states that the order of terms doesn't matter. The result will be the same. That is, swapping of terms will not change the product. Suppose x and y are any two integers, then x into y is equals to y into x. Example, 10 into minus 3 is equals to minus 30 is equals to minus 3 into 10. Multiplication by 0. If any integer multiplied by 0, the product will be 0. X into 0 is equals to 0, that is equals to 0 into x. Multiplicative identity. The multiplicative identity property for integers says that whenever a number is multiplied by the number 1, it will give the integer itself as the product. Therefore, the integer 1 is called the multiplicative identity for a number. For any integer x, x into 1 is equals to x, that is equals to 1 into x. Associativity for multiplication. The associative property of multiplication states that the way of grouping of numbers doesn't matter. The result will be same. Let x, y and z be any three integers, then x into y into z is equals to x into y into z. Example, 1 into 2 into minus 3 is equals to minus 6, that is equals to 1 into 2 into minus 3. Distributive property. The distributive property explains the distributing ability of operation over another mathematical operation within a bracket. It can be either distributive property of multiplication over addition or distributive property of multiplication over subtraction. For any integers x, y and z as x into y plus z is equals to x into y plus x into z. X into y minus z is equals to x into y minus x into z. For example, minus 5 into 2 plus 1 is equals to minus 5 into 2 plus minus 5 into 1, which equals to minus 15. Division of integers. Rules for dividing integers. When you divide two integers with the same sign, that is, positive divided by positive will give positive. 16 divided by 8 is equals to 2. When you divide two integers with two negative signs, that is, negative divided by negative will give positive. Minus 16 divided by minus 8 is equals to 2. When you divide two integers with one negative sign and one positive sign, that is, negative divided by positive gives negative. Minus 16 divided by 8 is equals to minus 2. Division of three numbers. Example, when the three integers are given, that is, minus 20 divided by minus 5 divided by minus 2, we follow the steps. Step 1. Divide first the two integers, that is, minus 20 divided by minus 5. In the step 2, we will get it as 10, and that we divide it with the third integer minus 2. 10 is positive as negative divided by negative is positive. In step 3, we get the answer as minus 5. Positive divided by negative is negative, hence minus 20 divided by minus 5 divided by minus 2 is equals to minus 5. Properties of division of integers. Division is the inverse operation of multiplication. Dividing 24 by 4 means finding an integer which, when multiplied with 4, gives us 24. Such an integer is 6. Since 6 into 4 is equals to 24, so 24 divided by 6 is equals to 4 and 24 divided by 4 is equals to 6. Division of negative integer by positive integer. Step 1. First, divide them as whole numbers. Step 2. Then put a minus sign before the quotient. We thus get a negative integer. Example, minus 10 divided by 2 is equals to minus 5. Minus 32 divided by 8 is equals to minus 4. Division of a positive integer by a negative integer. Step 1. First, divide them as whole numbers. Step 2. Then put a minus sign before the quotient, that is, we get a negative integer. Example, 81 divided by minus 9 is equals to minus 9. 60 divided by minus 10 is equals to minus 6. Divide a negative integer by a negative integer. Step 1. Divide them as whole numbers. Step 2. Then put a positive sign. That is, we get a positive integer. Example, minus 15 divided by minus 3 is equals to 5. Minus 21 divided by minus 7 is equals to 3. Closure under division. Division of integers doesn't follow the closure property. For example, minus 12 into minus 6 is equals to 2. Result is an integer. Minus 5 into minus 10 is equals to minus 1 by 2. Result is not an integer. We observe that integers are not closed under division. Commutative property of division. Division of integers is not commutative for integers. For example, minus 14 divided by minus 7 is equals to 2. Minus 7 divided by minus 14 is equals to 1 by 2. Minus 14 divided by minus 7 is not equals to minus 7 divided by minus 14. We observe that division is not commutative for integers. Division of an integer by 0. Any integer divided by 0 is meaningless. Example, 5 divided by 0 is not defined. 0 divided by an integer other than 0 is equal to 0. Example, 0 divided by 6 is equals to 0. Division of an integer by 1. When we divide an integer by 1, it gives the same integer. Example, minus 7 divided by 1 is equals to minus 7. This shows that negative integer divided by 1 gives the same negative integer. So, any integer divided by 1 gives the same integer. Given here are the two more examples. Solve them by yourself and verify your answers. Thank you and have a fun-filled learning.